In Module 3, we talked all about our brains and nervous system at the first or lowest level of psychological processing. In this module, we'll begin exploring the transition between our biology, what's happening at the level of our neurons, and our conscious experience. How do we become aware of the things around us, the sights that we see and the sounds that we hear? Everything we see, hear, touch, taste, and smell first starts out there somewhere in the world. So how does what's out there get inside our heads? First, our bodies must detect some kind of physical energy in the environment. Different forms of energy, such as light waves, sound waves, or physical pressure, correspond to different senses, such as sight, hearing, and touch. This is the process of sensation. Second, our brains must then interpret this physical stimulation. This is the process of perception. In the remaining videos in this module, we will explore in more detail how sensation and perception work for each of our different senses. For now, in this video, I'll describe more generally the processes of sensation and perception as they apply to all senses. In order for our brains to have a conscious experience of the world around us, our sensory organs must first detect some kind of stimuli in the environment, be it a sound wave, light wave, chemical in the air, etc. To do this, however, there must first be a sufficient amount of that stimulus that is present. If a stimulus is very faint, like the sound of a whisper in another room in the house, you may not be able to detect it. Instead, researchers have determined that for each of our senses, we have what's called an absolute threshold, which is the minimal amount of stimulation needed in order to correctly detect a stimulus at least 50% of the time. The sensitivity of our sensory receptors is actually pretty remarkable. For example, there are some estimates that we can detect a candle flame up to 30 miles away on a clear night. Under quiet conditions, the receptor cells in the ear can detect the tick of a clock up to 20 feet away. It's also possible for us to get messages that are presented below the threshold for conscious awareness. These are called subliminal messages. Historically, there's been some fear regarding so-called subliminal messaging. For example, you may have heard of a famous study from the 1950s showing that when the word popcorn was flashed on the theater screen very quickly, so quickly that people couldn't consciously recognize it, the patrons were supposedly more likely to then go purchase popcorn. However, this all turned out to be a giant hoax. The experimenter of the study refused to make any of his data public, and there's no evidence that the study itself was even conducted in the first place. Research shows that people can process and respond to information outside of our conscious awareness. However, we're also not mindless zombies. When making a conscious behavioral decision, like whether or not to buy popcorn at the movies, subliminal messages are unlikely to have a large effect. Sometimes, researchers are interested not just in our ability to detect a stimulus in isolation, but also to detect a difference between two related stimuli. For example, imagine you're choosing a font color on a color wheel. The shade and intensity gradually change from one pixel to the next. But at what point do you detect that the two shades of red are actually different shades? Here, we're no longer interested in the absolute threshold, but rather what's called the difference threshold, or also sometimes called the just noticeable difference. Unlike the absolute threshold, the difference threshold changes depending on the stimulus intensity. As an example, imagine picking up a 5-pound weight and a 10-pound weight. It's probably pretty easy to tell that the 10-pound weight is much heavier. Now imagine picking up a 50-pound weight and a 55-pound weight. The 55-pound weight is still heavier by 5 pounds, but now you might have a harder time distinguishing which one is heavier. They probably both just feel really heavy. This basic principle, that bigger stimuli require larger differences to be noticed, is known as Weber's law. As another example, take a look at these two pictures. On each side, the lower square contains 10 more dots than the upper one. However, this difference is much more noticeable on the left side, where it's easy to tell that the bottom square has more dots. On the right side, that difference is hardly noticeable at all. When a stimulus crosses the absolute threshold and is registered by our sensory organs, it causes neurons to fire, just like we learned about in the previous module. This starts the process called transduction, where energy from the environment, in the form of light waves, sound waves, mechanical touch, etc., is converted into electrical signals that the brain can understand. After external stimuli is transduced or converted into electrical signals, our brain processes and organizes this information to help us construct our conscious experience. This psychological process of making sense of stimuli is called perception. Perception involves both bottom-up and top-down processing. In bottom-up processing, the process starts with sensory input from the environment, which then works its way up to our brains to inform our conscious experience. In top-down processing, the process starts instead with our minds, our prior beliefs, knowledge, and experiences, which then work down to influence how incoming sensory information is perceived. As an example, look for a moment at the following picture, which is also in your NOBA reading for this week. My guess is that you likely had no trouble reading the sentence, "I love Paris," in the springtime. But did you notice that there are actually two thes? If not, what do you think happened? First, your eyes had to detect light waves as they bounced off the computer screen. Your eyes correctly sent this information to your brain for processing. That's the bottom-up part. However, when it came to interpreting the picture, your brain tried to make sense of the image not only by taking into account the literal physical sensory input from your eyes, but also by recruiting expectations based on your prior experience. Your prior experience tells you that a second "the" is unnecessary, so your brain quickly ignored it while reading the sentence. That's the top-down part of perception in action. As a side note, this is why it's often really helpful to have somebody else edit your papers for grammar and spelling errors. All of our physical senses rely on both bottom-up and top-down processes. This means that our perception of reality, while often quite good, is not always perfect and can sometimes even be tricked in predictable ways. We'll talk a little bit more about this in the next video when we talk about optical illusions. However, although our minds can sometimes trick us, overall, our brain is pretty remarkable at helping us make sense of our environments. Having this top-down process is actually very helpful because we have millions of sensory inputs that we must process every single day. I mean, think for a moment about every single tiny stimulus you must see, hear, touch, taste, and smell on any given day. Our brain somehow has to take in all of that information, organize it, and help direct our attention to what matters most so that we can respond effectively to our environment. In this video, we talked about sensation, the physical process of detecting stimuli in the environment and transducing those stimuli into neural signals, and perception, the psychological process of interpreting and making sense of those physical stimuli. For the exam, you should be able to define and explain the difference between sensation and perception, define absolute threshold and difference threshold, define transduction, and explain the difference between top-down and bottom-up processing.